White holes are one of the most puzzling predictions of general relativity, existing as theoretical counterparts to black holes. While black holes trap everything within their event horizon, white holes expel all matter and energy, allowing nothing to enter. No observational evidence has confirmed their existence, yet they emerged naturally from Einstein's equations as time-reverse black holes. Some theories suggest that black holes might eventually transition into white holes through quantum gravitational effects, while others propose that the Big Bang itself was a white hole event. However, white holes contradict the second law of thermodynamics, creating a major challenge to their existence. If real, they could be key to understanding wormholes, information paradoxes, and even time reversal in physics. Could these hypothetical objects exist in our universe, or are they simply mathematical artifacts of relativity? True or false? A white hole's event horizon prevents anything from entering, just as a black hole's event horizon prevents anything from escaping. True. Which of the following is a fundamental difference between black holes and white holes? Black holes allow matter to enter, but not escape, while white holes allow matter to escape, but not enter. Fill in the blank. A white hole's event horizon functions as a point of no blink for incoming matter. Entry for incoming matter. Fill in the blank. The idea of white holes emerges naturally from Einstein's equations as the blank solution to a black hole spacetime geometry. Time reverse. Some physicists propose that black holes could transform into white holes due to which phenomenon? Quantum gravitational effects. Fill in the blank. If a white hole were observed, it would likely be among the blank objects in the universe. Brightest. True or false? If a white hole existed, it would be stable over cosmic timescales, just like a black hole. False. Theoretical models suggest that white holes would be highly unstable, violating known physical laws, particularly the second law of thermodynamics. Fill in the blank. A controversial theory suggests that the entire observable universe may have originated from a single massive blank. White hole. If white holes exist, what would be their most likely observational signature? Intense bursts of energy without any apparent source. Fill in the blank. Unlike black holes, which continuously accumulate mass, a white hole is expected to blank over time. Shrink. True or false? If white holes exist, they must have formed at the same time as black holes. False. Black holes form from collapsing stars, but white holes do not have a known formation process. Some theories suggest they could emerge from quantum gravity or exist as remnants of evaporated black holes. Fill in the blank. If white holes exist, they would violate the second law of blank, which states that entropy must always increase. Thermodynamics. One speculative hypothesis suggests that white holes could explain which of the following cosmic events? The origin of short-duration gamma-ray bursts. Fill in the blank. Some theories propose that white holes and black holes could be connected by a blank. Wormhole. Fill in the blank. In most models, a white hole would collapse into a blank almost immediately due to instabilities. Black hole. If white holes exist, why have we never observed one? And what challenges do scientists face in detecting them? White holes remain purely theoretical because no natural process is known to form them. Unlike black holes, which form from collapsing stars, white holes would require matter to be ejected from an event horizon without an energy source, contradicting thermodynamics. Additionally, white holes may be unstable and could rapidly collapse into black holes due to minor perturbations. Detecting them is difficult because there are no confirmed observational signatures, though some speculate that gamma-ray bursts might be linked to microscopic white holes. Until observational evidence is found, white holes remain a mathematical possibility rather than a physical reality. True or false? White holes violate causality by allowing matter to appear without a cause. True. Which of the following fundamental principles is most clearly violated by white holes? The second law of thermodynamics. Fill in the blank. Fill in the blank. The full analytic extension of the Schwarzschild metric contains both a black hole and a blank. White hole. A theoretical white hole is expected to eject matter at 60,000 kilometers per second. If its total ejected mass needs 5,000 years to fully escape a gravitational radius of 0.5 light years, how long will it take to reach that distance? To calculate how long it takes for white hole ejecta to travel half a light year at 60,000 kilometers per second, we divide the total distance, about 4.73 trillion kilometers, by the velocity. The result is roughly 78 million seconds, or 2.5 years. This demonstrates how fast white holes would expel matter on cosmic scales. What aspect of general relativity allows the theoretical existence of white holes? The Schwarzschild solution. A white hole is modeled to eject particles at 90,000 kilometers per second for 20 seconds before collapsing. How far would the ejected matter travel? If a white hole expels matter at 90,000 kilometers per second for 20 seconds, we multiply the speed by time. The ejected particles would travel 1.8 million kilometers before the white hole disappears or collapses, nearly 5 times the distance from Earth to the Moon. True or false? According to loop quantum gravity, a black hole could tunnel into a white hole over infinite time. False. Loop quantum gravity predicts this transformation could happen over a finite but extremely long timescale, not an infinite one. Fill in the blank. According to some quantum gravity models, a white hole could emerge from a black hole after it finishes blank. Evaporating. In some theories, what lies between a black hole and a white hole in spacetime? A wormhole. Fill in the blank. In classical general relativity, white holes are considered blank solutions of Einstein's field equations. Time symmetric. True or false? According to loop quantum gravity, a black hole could tunnel into a white hole over infinite time. False. Loop quantum gravity predicts this transformation could happen over a finite but extremely long timescale, not an infinite one. Fill in the blank. Microscopic white holes, if they exist, would emit bursts of blank radiation. Gamma radiation. What causes white holes to be considered non-physical in most models? They require fine-tuned initial conditions that are not physically realistic. If a white hole ejects energy that reaches a star 3 times 10 to the 12 kilometers away in 100,000 seconds, what is the average speed of the energy pulse? To determine the average speed of a white hole's energy pulse, we use the formula: speed equals distance divided by time. The total distance is 3 times 10 to the 12 kilometers, and the time is 1 times 10 to the 5 seconds. Dividing 3 times 10 to the 12 by 1 times 10 to the 5 gives us 3 times 10 to the 7. Therefore, the average speed of the energy pulse is 3 times 10 to the 7 kilometers per second, or 30 million kilometers per second. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy friends.